Hello everyone. Today we're going to talk about the right triangle trigonometry. And this section actually belongs to 4.3 material. So if you're starting to work on your homework, make sure you're starting on the homework 4.3 instead of 4.2. And later I'll post another video about the section 4.2. Okay? So let's take a look at it. So in order to we're trying to get a right triangles in here with a 90 degree. And then we have a theta, which is our angle we wanted to find out. Then we find a C, we get an A, and we get a B for those lengths. And there is totally 6 of the trigonometry functions, and I'm gonna write it down here for you. So sine of this theta is equals to B over C, and cosine of the theta is equals to A over C, and we have a tangent of the theta is equals to B over A, and cotangent of the theta is equals to A over B, and we have cosecant theta is equals to C over B, and we have secant of theta is equals to C over A. Okay. So we have the 6 trigonometry functions in here. So one way you can think about to memorize this one is think about the theta. It's the angle you open up to, and then you can get it's a B over the longest length and C. And then cosine theta is in here is the other length you then use for the B and use it for A, and then it's over C. So that is the 6 trigonometry functions. In order to give you guys a little better idea what's going on, I'm going to give you an example and see how this works. So I'm going to give you a triangle in here, and that is pi over 6, which is the same thing as 30 degree. This is a right triangle. Okay, and I'm gonna give you all the length to it, which is 1 in here, 2 in here, and root 3 is in here. Okay, so let's go find out what's all the 6 trig functions it's going to be. Okay, so the 6 trig functions in here is actually going to be sine of pi over 6. That is, if you look at it, it's open up to this 1 and then with the longest length, so that will be 1 over 2. Okay. The same thing you can find is cosine, that's pi over 6. Again, we used the 1 already, so we have 1 left, which is root 3, and then over 2. So this is root 3 over 2. Okay. And the same thing will go on with using tangent of pi over 6. That is equals to 1 over root 3. And if you don't like this way to write, and I accepting you writing in this way, if you don't like this kind of writing, you can rewrite it, and then that turns out to be root 3 over 3. Okay? And then later on we have cotangent pi over 6, which is equals to root 3, because it's root 3 over 1, so which just root 3. Okay, and the next one is the cosecant of pi over 6, and that is equals to 2, because it's a 2 over 1, and then it turns out just be 2. Last one is the secant pi over 6. That's equals to 2 over root 3. And at the same time, if you don't like this writing, you can do it 2 root 3 over 3. Okay, so that will be a very nice example and to show you how those 6 trig functions is going to work. Okay, and after we talk about those 6 trig functions in here, and we're going to have some identities we're going to show you. Okay, and those one it's called a fundamental trig identities. Okay, So the fundamental trig identities. And those of trig identities are actually going to be very interesting because if you take a look at our examples right here, if you look at the sines in here compared to cosecant, and you can see the number they have in here is just the reciprocal, right? And that gives us the first trig identities, which is sine of theta is equals to 1 over cosecant of theta. They are the reciprocal of each other. Okay. At the same time, if you take a look at the cosine and secant, and they also the reciprocal of each other, and that gives us the second one, cosine of theta equals to 1 over secant of theta. Okay. And the next one, the last one, obviously, it's the tangent and cotangent, and you can see that it's also the reciprocal. So that gives us the third one. It's tangent theta equals to 1 over cotangent of theta. Okay. And obviously, if they are reciprocal of each other, and at the same time, the cosecant is also reciprocal of sines. So we can get another 3 formulas on top of this and tells us all that. So we have secant theta equals to 1 over cosine of theta. And at the same time, cotangent of theta equals to 1 over tangent of theta. So there's only one, there's 2 more formulas left, and they're not quite obvious. But if you think about it, if you take a look at the functions we have in here, we have a 1 in here, and we have a root 3 are the denominators for the trig functions, right? But if you take a look at that, the 1 is actually related into the numerators in tangent, and the root 3 is actually the denominator from the tangent. So from there, it gives us another 2 pair of identity, which is tangent theta equals to sine theta over cosine theta. And since cotangent is the reciprocal of tangent, so we can get cotangent theta equals to cosine theta divided by sine theta. Okay, so then we got this new 2 set of formulas right here, and that is worked out just perfectly for us. Okay, all right. So after we introduce of the fundamental trigonometry identities, there is a few more, and there is another whole set of identity. It's called the Pythagorean theorems identity. Okay. So this whole thing, it's called Pythagorean identity. So it's called the Pythagorean identities. And those set of identities are very unique. And I really want you guys to memorize at least the first one. And if the only thing I can choose for you guys to walk out of this whole trig class knowing only one thing, I would love you to remember the first identity, which is the sine square theta plus cosine square theta equals to 1. Okay. And this one, I think it's the most important identities out of all the trig functions in here. So I really want you guys to just memorize this one. Okay. And also from here, we got another 2 formula, which is tangent square theta plus 1 equals to secant square theta. And also cotangent square theta plus 1 equals to cosecant square theta. Okay. So finally, we have all these formulas lying down here. Okay. It's not a require. I want you guys to memorize all of this, but because on the test or something, and then I will allow you guys to use like a form, like a cheat sheets or like a note cards or stuff like that. But it will be very nice if you guys can memorize this stuff. At least you should memorize this formula right here. Okay, this is the most important one. Okay, all right. So after we have all these formulas written down, let's do some examples and using those formulas in general. Okay. Okay. So here's a new examples right here. Okay. So if I giving you one trig functions, I want you to find all the rest of 5 trig functions. How can we do that? Okay. So number 1, if tangent theta equals to 12 over 5. Okay. Tangent theta 12 over 5. What we wanted to do is to find the other 5 trig functions. Okay, so I use the FNS in here. It's the short for functions. Okay, so how do we find the rest of trig functions in here? So the best way I think is to use there's creating a triangle to make things happen. So let's get back into the topics we had in the very beginning. We have a triangles in here, and we call this one theta. Okay, and if you mark those labels too, you have A, B, and C in here. Okay, so from the previous trigonometry formula, we do know the tangent theta is equals to B over A. And seems from our equations in here, they're giving us the tangent theta is 12 over 5. So which means we can mark B as a 12 and A as a 5. Okay, so we can mark those things. And then later on, we can use the Pythagorean theorems to figure out the last length in here, which is A squared plus B squared equals to C squared. And that turns out C is going to be 13. Okay. And if you do the calculation, C turns out to be 13. Okay. So after that, and then we should just following our formulas like what we did. So sine theta is equals to B over C, which is 12 over 13. Okay. And then we have cosine theta, which is A over C, that is 5 over 13. And later on, we have tangent already, so we can get a cotangent theta, which is equals to pi over 12, which is A over B. So let me write it down here. So that is A over B, that's 5 over 12. Okay, so after this, then we have cosecant theta, which is equals to C over B, that is 13 over 12. Lastly, and then we have secant theta, which is equals to A over C over A, C over A, and that is 13 over 5. Okay, so this problem's right here, if you get, this is a very classic problems. You will see it very many times. And the problems in here is how can you make a triangle and complete all this length in here. After you're done with that, and then you should be able to use the formulas to find every single trig functions on top of that. Okay. All right. So a second problem, so I'm gonna give it to you. But this problem, I'm going to do things a little bit differently. I'm going to give you two of the trig functions